All right, so 8-4, again, last section. So hopefully there's not a ton of content on this test. That means it could be a good thing, okay? There are basically 4 theorems in today's notes, the one and the converse of it, and then 2 other ones, and they all deal with proportionality. So you're still dealing with ratios, cross-multiplying, all that good stuff that we've been doing. So the first one is called the triangle proportionality theorem. And what it says is that if a line parallel to one side of a triangle intersects the other 2 sides, then it divides those 2 sides proportionally. So you have to first start with a triangle. Second, have a side or a length drawn that would be parallel to one of the sides. In this diagram, that length is the EB, so that segment EB is parallel to DC, and I know that because it says it here. But you can also know that if it's marked like that, then I know those are parallel. If that's the case, then these sides are proportional, not necessarily equal, but proportional. So if I just put like an X, Y, and an A, B, so we don't have to write out all of the letters, okay? I can say that X over Y equals A over B. So I could go left over left, right over right, top, bottom. Or I can go across this way and say X over A equals Y over B. And you can even reverse that. I could like flip it and go Y over X and B over A, or B over Y and A over X. You just can't crisscross these. I can't put X over B and A over Y, okay? But technically for each of these, there are 4 ways to set up a ratio. Because I can go left, right, top, bottom, bottom, top, or right, left, okay? You just can't crisscross, yeah.
Are the small and the big triangles similar?
They are similar because those lines are parallel, so the corresponding angles are congruent, right? That's why this theorem works that way. The corresponding angles are congruent, which means those are similar because of angle similarity.
Only I knew about this theorem before.
Well, but it's not that it only applies when it's parallel, so not all similar triangles would work this way. Yeah.
I don't really understand it.
So, I mean, you're going to see an example, but let's say you're going to get given one of those 4 side lengths. No, you're 3 of those 4. Like, let's say this is 2, 5, 7, and X. Then I can put 2 over 5 equals 7 over X. Or I could go 2 over 7 equals 5 over X. You can go top, bottom, or left, right. You just have to follow that pattern.
Okay.
The only thing you can't do is like 2 over X equals 7 over 5. That does not work. Okay, the second one is the converse to that. Converse means flip the if then, right? So now it says if a line divides 2 sides of a triangle proportionally, then it's parallel to the 3rd side. So if this over this equals this over this, or vice versa, AB over BC equals AE over ED, like what's written there, then I can say that these 2 lines are parallel. And that would be because you can prove those to be similar triangles, and if they're similar triangles, the angles are congruent. If the angles are congruent, then those lines are parallel, so it kind of works backwards. It's just a shortcut. This, you'll see way less common than the first one. Like more than often, we're finding the lengths of the sides rather than proving that they are parallel, but this obviously is still a theorem. So this is the converse to the triangle proportionality theorem. All right, so here's what it could look like. In the diagram that's there, you obviously have a triangle within a triangle, so that's what it's always going to look like. And this time the parallel marks are already on there. There's no other instructions that are needed as far as information about these triangles. Because those parallel lines are on there, I know that the sides are divided proportionally. So CD, which is this one, over DA is that one, would equal what?
CE over EB.
Good. CE over EB. So this time you went bottom, top, bottom, top. B says if CD is 3 and DA is 6 and DE, which is this segment here, is 3.5, then what's AB? Now, what's given to you on the right is the sides, but what's given to you on the other side is not the side. It is the bottom or top side, technically, of those triangles.
So it would be 7?
So, nope. Instead of doing it proportionally like that theorem works, you have to set it up as though it's a similar triangle. So I can say 3, which is the right side of the smaller triangle, over the whole side of the big triangle, which is 9, would equal the top side of the small triangle, 3.5, over the top side of the big triangle. The difference is we're using similar triangles here. We're not using the theorem yet because the theorem would just be the sides, not the part that's not divided, which is the top of these triangles this time. So then I would reduce. This would be 1 to 3. And then I would cross multiply. 3 times 3.5, which is 10.5. Sure. So again, that was not the theorem. That was the similar triangles. Okay, now we're going to go to C, and it's new information. C says CB is 12, EB is 8, CD is 6, and you want to find DA. Now we're dealing with the sides of the triangle that are divided proportionally, so we can set up ratios and cross multiply, or set up a proportion, cross multiply. On the right-hand side, I've got the X and the 6. On the left-hand side, I have the 8 and the whole thing. How can I get that bottom part? How can I get just this segment so that I can use it against the 6? Good. 12 minus 8 would be? 4. And now I can do it a couple different ways, but I can do 8 over 4, so top over bottom would equal X over 6, top over bottom. Or I could do 8 over X, left, right, equals 4 over 6, left, right. Or I can flip-flop them and go back the other way. Obviously, the top one's easier, right, because 8 and 4 reduce. So look for stuff like that. That would be 2 over 1. 2 over 1 equals X over 6, so X equals 12. Same thing with the bottom. If I cross multiply, if I simplify, this would be 2/3. And I'd get 24 equals 2X, and X would equal 12. So it doesn't matter how you set it up, you should get the same answer. If you have extra time in the test, you might even want to set it up twice and then check your answer.
I always have time with the test.
Good. Question on those? Yeah.
Does the order matter? Like you put X over 8 or 8 over X and 6?
Correct. So as long as you're consistent. So if I go X over 8, I have to go 6 over 4. Yep. It doesn't matter as long as you're consistent. And you don't crisscross. 8 cannot go over 6 and X over 4. Like you can't do it that way. All right. Third theorem is called the 3 parallel lines theorem, and it's dealing with 3 parallel lines. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. So picture it almost like your triangle. There are going to be 4 segments once you divide it. And so in this segment, you can say ABC over CD equals AF over FE. So we went from the right side, top, bottom, to the left side, top, bottom. I'm going to, again, use just single letters so that we could make it a little bit easier. We could also say A over B equals X over Y. So left top to left bottom, right top to right bottom. Or we could say A over X equals B over Y. Or we could reverse both those. Okay, so you can go top, bottom, left, right, as long as you follow the same pattern. All right, so this one, again, the diagram is all you need because the diagram shows that there are 3 parallel lines and they are cutting segments from 2 transversals. A says if A is 2, and B is 3, and C is 5, find D. I don't even need to make it next. I can just leave it as D. So what's one way to set it up? Yep.
I just have 2/3 equals 5/x.
Good. 2 over 3 would equal 5 over, I'm just going to leave it as D so we know, but yes. How else? Yep. 2 over 5, 3 over X or D. Or I could reverse them. 3 over 2 equals D over 5, and 5 over 2 equals D over 3. Any of those four give you the same answer. So I'm just going to solve the first one because there's no like real advantage to either of them. So 2 times D would equal 3 times 5, which is 15. And then divide both sides by 2. And D equals 15 over 2, or 7.5, or 7.5. You can leave it improper. Usually on lengths, they will go to the next step and they will actually take that and make it into a decimal. So when you're checking your answers, that might be what it is. But you can all also take 15 over 2. Questions on that one? All right, then go to B. And B says if A is 4, B is 8, C is 5, find C plus D. What's one way to do it? Because there's multiple ways to do this. So,
Just do A over B equals, C over, like, okay, 4 over 8 equals 5 over X.
Yeah.
Just solve for D and then add, C and D.
okay, that works. So we're going to do this. 4 over 8 equals 5 over X. We're going to make this 1/2. And then I'd get X equals 10. That gives me this part of my segment. It wants the whole thing, so I'm going to add the 5 and the 10 to get 15. That is one way to do it. That's probably the easiest way to do it. I'd probably recommend that, but it's not the only way because you can do 4 to the whole thing equals 5 to the whole thing. So I could say 4 over 12 equals 5 over X, and it will give you the whole thing. Okay? I would get 4X equals 60 and X equals 15. So either way works. I think the first way is easier because you just have to add at the end instead of having to worry about combining the other side. Mars.
How did you get 12 again?
I added these two. So I did just the top part to the whole side on the right. So I have to do just the top part to the whole side on the left. So I added the 4 and the 8. Questions on that one? All right, last theorem of the chapter and the notes for today, triangle angle bisector theorem. It says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the side lengths of the other two sides. Yeah, it's a mouthful. But it's the same concept. An angle bisector this time is cutting the opposite side into two segments that are proportional to the two sides that are not intersected. So in the diagram that's there, we know it's an angle bisector because of the arc there. It could also tell you like angle ACD equals angle DCB in the instructions. That would do the same thing. So then it's saying AD over DB, so the two segments that it cuts into, would equal AC, which is the side that intersects the top one, over CB, which is the side that intersects the bottom one. So I'm going to do X, Y, A, B again, just to shorten this. So we just did Y over A equals X over B, and you did top of the intersected part to the bottom. So I have to do top side to the bottom side. That was the order there. I can also do top to top and bottom to bottom. So I can do X over Y, side over segment, would equal B over A, side over segment. You just can't crisscross like we can't do with the other ones. Go. Questions on that one? So the first and the second are basically converses of each other. The third is the parallel lines. The fourth is the angle bisectors.
Why is there a sign labeled A if there's already a A?
It's a lowercase a. I used a different variable. I apologize, I confused you. All right.
I'm confused.
Last example. So I've got my angles that are marked as congruent here, right? That's how I know it's the angle bisector one. And then there's a couple different ways to do this, but I could say that 12 over 10 equals 24 over whatever this segment is. Or I could say 10 over whatever that segment is equals 12 over 24. And so you could do this a couple different ways. One is actually name that segment as x minus 10, because if the whole side is x, then that segment would be x minus 10. The other is give it a random variable, solve for it, and then add the 10 and that random variable. So I'm going to show you how to do both. So the first is this. If that whole side is x, then the missing part is x minus 10. So then I can set up a proportion, like I could do 12 over 10. I went side and segment would equal 24 over segment x minus 10. Or I could do segment over segment, so 10 over x minus 10 equals 12 over 24. You could do it that way too. They both simplify, but the one on the right, obviously 12 and 24 simplify a little bit more, so that might be easier, 1 over 2. And then cross multiply, I get 20 equals x minus 10. Add the 10, and x is 30. So in that scenario, I don't have to do any extra work after that. That is my answer.
And you just have to plug it in?
No, you don't. Not on that one.
Why?
Because I made it x minus 10, so x is what I'm looking for. If I changed it and I invented like some other variable, like let's say this is y instead of x, and I solve for y, then at the end, I have to add 10 and y. So I can do 10 over y equals 12 over 24, 1/2, and I get y equals 20. And then if this is 20, I have to add these together to get the x. Either of those work. So like whichever one made the most sense in your brain, go with that method because they both work. Questions?